Despite global technological advances during the last century, over 1 in 10 people worldwide do not have access to a clean source of drinking water, according to the World Health Organization. The Rohingya refugee camps in Bangladesh are one example of where people's lives are threatened by lack of access to clean water. Earlier this year, Jason Beaubien of NPR reported on the growing concern of aid workers for the safety of the refugees.
The monsoon rains tend to start in April, and at their peak dump 20 to 30 inches of rain a month on this area. Kearney at UNHCR says the challenge is to provide basic sanitation to a population the size of Denver or Boston before the camps turn into a muddy mess.
I mean, you're looking at developing all the water sewage infrastructure from scratch in the mountains, in the hills, without road access, without many materials. Tricky.
Without proper treatment, water can act as a carrier for pathogens that cause diseases such as cholera, typhoid, dysentery, hepatitis, and more. All told, lack of clean water is responsible for the death of an estimated 1.5 million children every year. With the pressures of population growth, climate change, and population displacement, the need for large-scale water purification is critical. This season on Engineering Out Loud, we're focusing on efforts happening here at Oregon State University to address the challenge of providing clean water. From the College of Engineering at Oregon State University, this is Engineering Out Loud. I'm Owen Perry, and today we'll talk about the work of a group of researchers in the Humanitarian Engineering Program who are helping to create a novel water purification system designed for the developing world, and how they're looking outside the engineering toolbox to make sure it's a product that will truly make an impact.
Paul Polak in his book Out of Poverty said that 90% of engineering design benefits 10% of humanity. So we're looking to try to use some more of the engineering design to benefit more of the bottom of the pyramid, where maybe people don't have the benefit of modern engineering so far.
That was Nordica McCarty, an assistant professor of mechanical engineering who is leading the project. Longtime listeners may remember Nordica from an earlier episode of Engineering Out Loud, way back in Season 2, when she talked about her work to improve the lives of people, especially women and children in the developing world, through more efficient, less polluting cook stoves. Here's a clip from that episode where she spoke with my colleague, Keith Hautala.
Whenever we want to prepare a meal or even a quick snack, we can just turn a knob and, like magic, an electric burner lights up, or a clean blue flame if you're cooking with gas. But you might be surprised to learn that for nearly half of the residents of planet Earth, this kind of luxury just simply doesn't exist.
About 40% of the world's population is currently cooking with biomass to prepare their meals and heat their water and heat their homes. And this is primarily done inside. And so you can imagine if you've ever sat around a campfire, you know that biomass fires produce a lot of smoke. And so being in the same time and confined space that cooking is happening, women and children are suffering severe health effects because of this necessary practice.
As it turns out, indoor air pollution is actually a huge problem in the developing world, where smoke inhalation and related illnesses are among the leading killers of women and children, accounting for about 4 million premature deaths each year.
To put that in relative terms, that's like the population of Los Angeles dying every year simply because they're cooking their meals to feed their families.
In the rest of that episode, Nordica goes on to describe her work developing clean-burning, highly efficient cook stoves designed to alleviate environmental hazards of cooking over open fire. This episode is something of a follow-up. Last time we were talking about fire, and today we're talking about water. Well, really we're talking about both. Today, millions of people around the world purify their water by boiling over an open, biomass-fueled campfire. In addition to the health and environmental risk, boiling water this way is a huge time suck and also contributes to deforestation. One company here in Oregon thinks they might be onto a solution to those problems, and they've partnered with Nordica and her team to make it a reality. InStove is a nonprofit that designs institutional cook stoves for places like orphanages and schools and feeding centers in rural, low-resource communities or refugee camps. Recently, they've also added a water purification system that fits inside the stove, which McCarty and her team helped design and test.
I'm Nick Moses. I'm a master's student working for Dr. McCarty, also in the Humanitarian Engineering Program.
Conveniently, Nick also works at InStove.
I'm in-stove staff engineer, so my role has sort of been as an advisor to the guy who's familiar with the system and how it works and how it can be used and tested and all those things.
I'm Grace Burleson, and I'm in the same program as Nick.
As part of the humanitarian engineering program, Nick and Grace are getting degrees in both engineering and anthropology, and they're using skills from both disciplines for this project.
I've been working on it as part of my master's thesis, which is looking at more efficient ways to improve the pasteurization or the boiling water process. And so this product is at the center of the research for me.
So let's pause for a second. What is this product? What makes it so promising?
It's like the same size as a 55-gallon oil drum, except it's green and it has a chimney in the back.
And a pot sunken into the top of it.
Okay, it's a little more than a green oil drum with a chimney and a pot. At the heart of these stoves is an insulated metal combustion chamber that concentrates heat and mixes combustion gases to create operating temperatures that literally burn up the smoke. This produces a fire that is cleaner and more efficient than is possible otherwise. The added water purifier is a gravity-fed unit that kills microorganisms by heating water to the pasteurization temperature of 71 degrees Celsius.
InStove actually reduces the energy required to purify a liter of water by 97%. So it does that by a really efficient system that uses a heat exchanger to recuperate the heat and cool the water back to room temperature before it exits the system. So the heat is not wasted. It's instead used to preheat the incoming water. So the system uses only about a pencil's weight of fuel to purify a liter of water. And because it's a flow-through system, it can produce enough water for up to 1,000 people per day.
Grace, Nick, and Nordica have done a lot of research on different ways to disinfect water, and the hundreds, if not thousands, of products out there aimed at solving this problem. There are products that distill water or use solar radiation or chlorine, but today, access to clean water is still a problem for millions of people. Why aren't these products working? Nick thinks he has a pretty good idea.
Interesting how much of that work is done here and how little of it is done in context or involving people. A lot of times these products are like sold to an NGO or a government and not the user, or there's sort of a missing piece of that incentive to really understand what people want and what works for them, which I think I've seen in cook stoves too sometimes, but I definitely notice that with all these water technologies. Engineers, we're trained as specialists. We're the designers, the technical people, and that works if you go work at a corporation in a country like the United States because you work with people who do all those other things, who figure out the sales and the marketing and the business and the manufacturing and all the other details you need to bring a product to market or to the end user. But if you throw an engineer out into the world and have them try and design a humanitarian technology, they probably don't have that context and that background. And on top of that, they probably don't really understand the culture and the people that they're working with. It would be great if we could do all of those things, but the resources just really aren't there to have all of those skill sets.
So for this project, it's helpful that Nick and Grace are both trained as anthropologists as well as engineers.
Anthropology is kind of a good stopgap because it's at least really reflexive and critical and helpful at understanding what pieces are missing and what people need. So even if you can't solve every problem, you can at least identify what they are and try and get help.
Grace and Nick are really paving the way. They're the first two students to graduate from the humanitarian engineering program with this dual master's degree option, and we're really excited about continuing this model going forward.
There's a theory in social sciences called the diffusion of innovations, which provides a framework for how technologies move through societies and are adopted by people. It involves understanding reasons why someone would use something, but also the barriers that keep them from doing so.
You never want to design something and think that it's the solution for somebody that you don't know. 20 years ago, no one even thought they needed a smartphone. And that was something that companies like HP, Apple, Intel, they have teams of anthropologists and social scientists trying to understand what people want and what the next big thing is going to be. And then when they come out with that new technology, everyone goes and buys it and wants it. And I think we have to take a similar approach in development work. You have to really think, what do people want, so that when you bring them this technology, you're not convincing them and forcing anything onto them.
This anthropological approach has proved vital to the success of the water purifier project as they began testing it in the field.
I was the lead on a field study in Uganda, which focused on understanding cultural aspects and usability of the system within a society that is very used to boiling their water over open fires. So trying to compare their current methods of boiling over a large stove to using this pasteurization system and kind of seeing how they liked or didn't like this system.
Grace used the ethnographic methods she learned from her anthropology studies to observe participants.
I worked really closely with this one cook who every day had to prepare enough food and drinking water for 105 high school girls.
Imagine a high school dormitory in eastern Uganda. Twice a day, a cook boils water over a smoky, open fire so that 105 girls can drink safely. Each 80-liter pot takes roughly an hour and multiple logs to boil.
He was really used to using a large open fire, and so I spent a lot of time watching him cook and asking him about his process of cooking and of also boiling water. And then we implemented the system and did the exact same thing. So he used the InStove purifier, and I observed him and asked him what he liked about it, didn't like about it.
They also measured and monitored how much fuel was consumed.
It's really clear the difference in how much fuel the system uses, how much wood it uses. Way, way less wood per amount of water that you're producing, wood per time. And they were really excited about that because at least this particular location, they actually purchase their firewood. They use so much of it to boil water and to cook for that many people that they actually go purchase it from a local vendor rather than collecting it themselves. So it would save them a lot of money.
While her observations helped verify the purifier's efficiency, they also led to some significant changes to its design. The InStove purifier was designed to boil water quickly, but also to cool it rapidly enough that you can drink it without getting burnt. The problem is, in Uganda, people really like to drink tea.
They drink tea at almost every single meal. And so one thing that I realized is if they use this purifier, they would also have to heat up water in addition, because they're not going to just stop drinking tea. Something that InStove is looking into is, can we have a manual valve to change the temperature of the water flowing out of the system, depending on if you want to drink it immediately and have it be lukewarm, or if you want to have it come out a little bit warmer for tea.
Alongside the advantages of having anthropologists on this project, another key to its success has been strong collaboration.
Definitely a technology that we can implement to help bring about clean water in the developing world, but a project that certainly requires many disciplines to help succeed. Us as mechanical engineers certainly have contributed to the technical aspects, the heat transfer and the heat recovery and fluid flow type pieces of the design. But in addition to that, we've been working with colleagues across campus and across the world, really. So we've been working with Dr. Atala Nawab Daneshmand from Environmental Engineering, who's been helping us to do the microbiological testing to verify that we are, in fact, killing the E. coli and the viruses and the other bugs that might be in the water. So we can verify its performance in that regard. We're working with Dr. Brian Tilt in anthropology, who's advising Grace on the social evaluation pieces of the project.
Going forward, the team is looking to expand testing of the water purifier.
We're working with Dr. Molly Kyle in public health, who is connecting us with some of her colleagues at the Dhaka Community Hospital in Bangladesh, where we're about to install some of these systems in the Rohingya refugee camp.
Recently, 500 to 700,000 Rohingya people fled the genocide and violence in the country of Myanmar across the border to Bangladesh, where enormous refugee camps have been built. With the threat of monsoons, the risk of water contamination is high.
This could potentially be an ideal situation where they have a serious need for clean water, and this type of system could really help to address that need. So we need to work with those NGOs, non-governmental organizations on the ground to help to implement the system and train people at the medical clinics in these camps to operate and maintain the system. In these regions where the need is greatest, our understanding is often the lowest and the most lacking. So I think that's where bringing in multiple disciplines and different perspectives is critical to making the engineering designs succeed in these sort of contexts.
Thanks for listening, and thanks to Nordica, Grace, and Nick. To learn more about the Humanitarian Engineering Program at Oregon State, visit humanitarian.engineering.oregonstate.edu. This project is just a taste, or sip if you will, of some of the great work being done at Oregon State to harness science and engineering-based solutions to providing clean drinking water to the global community. You can hear more stories about other clean water projects at engineeringoutloud.oregonstate.edu. While you're there, hit the subscribe button or search Engineering Out Loud on your favorite podcast app. This episode was produced and hosted by me, Owen Perry. Sound design and editing was done by Molly Ayton. Our intro music is The Ether Bunny by Eyes Closed Audio on SoundCloud and used with permission of a Creative Commons Attribution license. Other music and effects in this episode were also used with appropriate licenses.